Hello children, welcome to our class. Now chapter 11, dual nature of matters and radiations. So we can see in that briefly photon, photoelectric effect, experimental setup to study the photoelectric effect, the effect of intensity, frequency, potential and potential energy current, and graphical representation of the variation of the potential energy current, and laws of photoelectric effect, Einstein's photoelectric equations, like one by one we will see, right, and the matter waves, de Broglie wavelength, everything. Now what are photon? See, photons, we can say that according to Planck's quantum theory of radiations, an electromagnetic wave travels in the form of what we said, discrete packets of energy that called a quanta. One quantum of light radiations, we can call it as a photon. Got it? So we can say a packet or a bundle of energy. That is only the meaning. The discrete packets of energy, which we can call it as quanta. That is the quantum of light radiations, which is coming in the radiation. This is called photon. So the energy of the photon, E, which is equal to h nu. So h nu we can say hc by lambda, right? So where h is the Planck's constant, nu we know that the frequency of the radiation or photon, c which is the speed of light, right? So what are the properties, or we can say the main features of the photon? See, the photon travels with the speed of light. So speed of light we know that 3 into 10 power minus 8 meter per second. So it has zero rest mass. So zero rest mass, that means the photon cannot exist at rest. And the kinetic mass of a photon, m, which is equal to E by c square, or we can say h by c lambda. The momentum p, which is equal to, we can say that mc, or we can say that h nu by c, or E by c, or h by lambda. So we can connect with that the lambda wavelength or the frequency nu with that momentum. And the photon travels in a straight line, right? And the energy of a photon depends upon frequency of a photon. So the energy of the photon does not change when photon travels from one medium to another. And also we can see wavelength of the photon changes in different media. So the velocity of the photon is different in different media. The photons are electrically neutral. The photons may show diffraction under given conditions. See, the photons are not deviated by the magnetic or electric field, right? So what is photoelectric effect? See, these are all the main features of the photons we have seen. With the help of these conditions, how the photoelectric effects and Hertz observations, all those things we can see. So photoelectric effect, which is nothing but the phenomenon of emission of electrons from a metal surface. Suppose electromagnetic radiations of sufficiently high frequency or incident on that a metal, we can call it as that phenomenon as the photoelectric effect. See, the photo, or we can call it as the light which generated in the electrons, are called the photoelectric effects. In the suitable frequency it should be. So electrons emitted by the effect, what we said, that is photoelectrons, and the current constituted by the photoelectrons, which we can call it as photoelectric current. Got it? So this you must know these 3 points. So what is photoelectric effect, photoelectron, and the photoelectric current? Now you must know the non-metals also show the photoelectric effect. Some of the non-metals show the photoelectric effects, and also the liquids, gaseous particles also show the effect. But some extent to that limit which is there. You can see one by one the UV ray that hit on a metal, it comes under photoelectrons, right? It emits photoelectrons. And see the metals and other alkalis, how it is gives. If suppose you have sent a visible light, no photoelectrons is coming out of the metals. And alkali metals, see that the visible metals which shows, the visible light we send through that alkali metals, only that it will show the photoelectric effect. And we can see now the experimental setup or experimental study of the photoelectric. See the diagram, it shows the experimental arrangement which used for the study of photoelectric effect, and it consists of an evacuated glass quartz, another metal plate also, that A which is the collector and C which you are seeing, that is the photosensitive plate. Okay, so the two electrodes are connected to a high tension battery, a potential divider which arrangement under the ammeter also, the micrometer mu A, which is also arranged. So now when monochromatic radiations of a sufficient high energy which is falls on a plate C, then the electrons are emitted and which are collected by the plate A. So the current which called photoelectric current, is it right? And flows in the outer circuit which measured by the millimeter micrometer mu A. Okay, so these are the way it getting, and monochromatic radiations, it is on the plate C and it is collected by A, and the current which falls we can call it as photoelectric current. Got it, children? Now we can see, right, with the help of the study of the experimental setup from the photoelectric, so we must know about what are all the effects of intensity of light on the photoelectric current. Right, now if we allow the radiations of fixed frequency to fall on a plate, see the accelerating potential difference between the two electrodes is kept fixed actually, right? Then the photoelectric current is found to increase linearly with the intensity of incident radiations. You can see through this diagrammatical represents. See, since the photoelectric current is directly proportional to the number of photoelectrons which emitted per second, this implies that the number of photoelectrons emitted per second is directly proportional to the intensity of incident radiation, right? And see that the next the diagram that will gives the variation of photoelectric current with anode potential. You're seeing that photoelectric current with the anode potential, that A, right? So this will shows if we keep the intensity, suppose the intensity and the frequency of the incident radiation fixed, the increase of the positive potential, that means we can call it as a accelerating potential. The positive potential we can call it as accelerating potential on plate A. See that gradually it is found that the photoelectric current is increases with the increasing in accelerating potential till what? Till a stage is reached when the photoelectric current become maximum, and it does not increase further with the increase of the accelerating potential. So the maximum value of the photoelectric effect we can call it as what? That we can call it as saturated current. That we can call it as saturated current. So now only we have seen that if we apply a negative potential on the plate A with respect to the plate C, and it increase a magnitude gradually, and it's seen that the photoelectric current decreases rapidly, right, and it becomes zero. So only that negative potential which occurs we can call it as that cutoff or stopping potential, right? So for the given frequency of the incident radiation. So these points you can take it for your notes purpose, so it's very useful, right? See all the points which is there, it will give for the effect intensity of incident light on photoelectric current. Okay, so now the next one is the effect of frequency of incident light on photoelectric current. See, to study the effect of frequency on the photoelectric effect. For a fixed intensity of incident light, the photoelectric current does not depend on the frequency of the incident light, because the photoelectric current simply depends on the number of photoelectrons that are emitted and in turn on the number of photons incident and not on the energy of the photon. See that the diagrammatical representation of, that means the graphical variations which have given for the photoelectric current with the anode potential for different frequencies of incident radiation. See, the intensity of incident radiation at each frequency is adjusted such a way that the saturation current is same each time when plate A is a positive potential. Is it right? So the potential on the plate A gradually reduces to 0, then increased in the negative direction till stopping potential which is reached. So this experiment is repeated with the radiations of at different frequencies. This only by showing this graph we can get it, the value of a stopping potential that is increases with the frequency of incident radiations. So the the graphs, the two graphs they have given, that is V2 which is greater than V1, and the corresponding stopping potential which is getting vary in the order of V2 which is greater than V1, like it is given, right? So this will give the effect of frequency of incident light on stopping potential. So however the saturation current is same, must know for the same for different frequencies of the incident light, and when potential is decreased and taken below 0, the photoelectric current decreases to 0, but at different stopping potential for different frequencies. This point, all the points is very important, unique information, each and every point which is giving. See, actually what we said that see, the stopping potential or maximum kinetic energy of the photoelectric increases linearly with the frequency of the incident radiation, but it is independent of its intensity. So we can see the next one is threshold frequency. What is threshold frequency? See, there exists a certain minimum cutoff frequency for which stopping potential is 0. Then the minimum value of the frequency of incident radiation below the photoelectric emission, we can say it stops altogether. We can call it as a threshold frequency. See, this threshold frequency, you are seeing that it shows there is a minimum value of frequency. We can say simply the minimum value of frequency, and below which photoelectric emissions is not possible. However, high the intensity of incident light may be, and it depends on the nature of the metal which emitting photoelectrons, right? So the next one, you must know the laws of photoelectric emission. So what are the laws? How it states the law? That is, on the basis of the experimental results on photoelectric effect, we can see the points. That is, for a given substance or for a given photosensitive material, there is a minimum value of frequency of incident light that's called, we can say, threshold frequency, that below which no photoelectric emission is possible. However, the intensity light also we can say, right? So the second point, the number of photoelectrons emitted per second, it is directly proportional to the intensity of light, provided the frequency is above the threshold frequency, right? And the maximum kinetic energy of the photoelectron is directly proportional to the frequency which is provided the frequency is above the threshold frequency. Below means it is not possible. The case is not possible for that, right? So next one is the maximum kinetic energy of the photoelectrons is independent of the intensity of incident light. And
The process of photoelectric emission is instantaneous, that is, as soon as the photon is suitable frequency falls on the substance, so it emits photoelectrons, and the photoelectric emission is 1-to-1 point, and for every photon is suitable frequency should need, and 1 electron is emitted means. Got it? So the photoelectric emission is an instantaneous process also, what we said. So time lag that between the incidence of the light radiations and the emissions of photoelectrons is very small, right? And particularly you must know about the points which are above the threshold frequency also. Got it? So these are all the laws of photoelectric emission, the conditions which we are getting, right? Thank you, children.